In this video, we're going to look at this example that is designed to compare two types of batteries and specifically their life length. And we compare them as essentially two populations, mean length of battery type 1, mean length of battery type 2. And the data that are collected for each type of batteries are based on the same 5 different toys. So that makes it a paired data because the subjects that we collected data from are the same subjects. They're the same 5 toys, and we are comparing battery type 1 and 2. So the type of test that we're going to use here is going to be paired t-test. The first question is, state the null and alternative hypothesis. So we are comparing mean length, life length of battery type 1, mean life length of battery type 2, and we want to see if there is any difference between them. We're not interested to check whether this one is more than that or the battery type 1 is more than 2. We're going to look at a two-sided test to see whether there is any difference in them. So your null hypothesis would be mu of differences, right? This is how we do the paired t-test. So let me indicate that here, paired t-test. Mu of differences be equal to 0, which means there is no difference between battery type 1 and 2. An alternative hypothesis, mu of differences is not equal to 0, which indicates there is a difference between them. So to conduct this test, we have to calculate the differences between battery type 1 and 2 for the n pairs of data that we have. So I'm going to have d sub I column here, and what I'm going to do is taking the difference between the data points for n pairs of data. This is the first pair, 52.6 minus 61.4, that is negative 8.8. Well, I have to indicate here that I'm choosing to do battery type 1 minus battery type 2. You can do the battery type 2 minus 1. But you have to be aware of what type of test did you do. So when you're interpreting the results of your test, you know whether you did the type 1 minus 2 or type 2 minus 1. So I'm going to take the differences here for all these 5 pairs of data. So now I have the d sub I data, and this is the data that I'm going to apply the paired t-test on. Now that I have that, going to part B, identify the test stat and the critical region using alpha of 5%. So the test statistic for paired t-test is the t-score. I need to find out what is d bar, average of differences, and standard deviation of differences. Average of differences, or d bar, is essentially d1 plus d2 all the way to d5 over 5, which is average of this data. And when you calculate the average, that is negative 6.18. I also need standard deviation of differences. And the formula for calculating standard deviation of a data set is summation of I from 1 to n. In this case, n is 5. d sub I minus d bar squared over n minus 1. So what I need to do is to take the difference between my data points, which are 5 of them, and the average, and this is the average, square them, sum them up, divide them by n minus 1, and take the square root. So that will be, so the first data point is negative 8.8. So negative 8.8 minus d bar, which is here. So minus negative 6.18 makes it plus 6.18. And I'll do that for the other 5 data points. So when you do this calculation for all of them, the standard deviation of differences would be 4.73. So now I have the standard deviation, I have the d bar, I can calculate the test stat. In this case would be negative 6.18. My delta naught is 0. 4.73 divided by square root of 5. And if you do the math here, your test stat is negative 2.93. Now I have to see if that is in the critical region or not. The critical region for the paired t-test is starting at t of alpha over 2 and n minus 1, this is for a two-sided test, negative t of alpha over 2 and n minus 1. In this case, alpha is 0.05, so we're looking at t of 0.025 and n minus 1 is 4. And same here, negative t of 0.025 and degree of freedom 4. I have to go to the t-table and look this number up. So here we're at the t-table, and we're looking at 0.025 and degree of freedom of 4. So this is our t value that we're looking for. Now that is 2.776, negative 2.776. Now here, by looking at the test of statistic and the critical region, you'll see that we are in the critical region. If I want to graph this out for you, this is the t distribution that we have. 0 looks like our critical region starts at 2.776, negative 2.776, and the test stat is right here. So we basically say, since our test stat is less than negative 2.776, we reject the null hypothesis. And the null hypothesis was there is no difference between battery type 1 and 2, and we rejected that, meaning that there is a difference. But which one is bigger than the other? Well, your test statistic is negative, and that indicates that because we did mu1 minus mu2, looks like mu2 is greater than mu1. But we can further investigate that with doing confidence interval. Let's look at part C. State the conclusion resulting test using p-value. So we need to calculate the p-value here. And the p-value for a two-sided paired t-test is 2 times probability of t with degree of freedom of m minus 1 greater than absolute value of t-score. So 2 times t of 4 greater than 2.93. We need to find this probability from the t-table. So here we're at the t-table and we're looking for probability of t4 greater than 2.93. Well, T4 means the degree of freedom of 4, so this is the row that we're looking for, and then we're looking at these numbers, see where do we get more than 2.93. 2.93 is somewhere here between these two numbers. You can approximate what probability is associated with that. 2.93 is between these two, and these two are associated with 0.025 and 0.01. Because 2.93 is closer to 2.776, you pick a number between these two numbers but closer to 0.025. So I'm going to go with 0.02, let's say. We can approximately say that this is 0.02. Again, we can calculate this more accurately using statistical packages, or even with interpolation, linear interpolation, we can do that. But I think this is close enough. So that is equal to 2.02, that is 0.04. Well, here p-value is less than alpha, because alpha of our test is 0.05, so we reject the null hypothesis. So since p-value of 0.04 is less than alpha of 0.05, we reject the null hypothesis, and this is the same decision that we concluded using the critical region method. For part D, we're constructing a confidence interval that is relevant to this problem, meaning that it's going to be a two-sided confidence interval. And we want to verify the conclusion that we identified in part C. So let's construct a confidence interval here. So confidence interval is going to be a two-sided confidence interval, and that is mu d is between lower confidence limit here and upper confidence limit here, and that is d bar minus t of alpha over 2 n minus 1 times standard deviation of differences, square root of n. Now if I replace the parameters with the numbers that we have, the confidence interval be so the confidence interval after replacing these parameters with the numbers that we have will be between negative 12.04 and negative 0.32. And since this confidence interval does not contain 0, which is our delta naught, does not contain 0, we reject the null hypothesis. Meaning that the difference between mu1 and mu2, mu1 minus mu2, is on the negative side. This, with 95% confidence, is negative, which indicates mu2 is probably bigger than mu1. Battery type 2 has a longer life than battery type 1 because the confidence interval is entirely in the negative side. So since 0, basically, which is our delta naught, is not in this confidence interval, we reject the null hypothesis, which is the same decision we ended up with using the other two methods.